Hypothesis testing, Chapter 8, is a very interesting chapter. We will be testing for true population mean, true population proportion, true population variance, and true population standard deviation. The same parameters as in Chapter 7. We have a z-test for the mean, a t-test for the mean, a proportion z-test for true population proportion, a chi-square test for true variance, and a chi-square test for true standard deviation. Hypothesis testing can be broken into 5 steps. There are 2 methods, traditional method versus the p-value method. For every section of Chapter 8, I will first teach you the traditional method, and then I will teach you the p-value method. Regardless of method, the answer, or what I would say the decision and the summary statements, will be the very same for every single word problem. The steps with the traditional method are stated here. State the hypotheses and identify the claim. Find the critical values from the appropriate tables. That would be the z-table, the t-table, or the chi-square table. For the very first type of test for the mean, either it will be a z or a t. It's a z-test if sigma is known or n is at least 30. It's a t-test if sigma is unknown and n is less than 30. Then we will compute a test statistic from formula, and I will give you those formulas for each section. Then we will make the decision to reject the null hypothesis or do not reject the null hypothesis. That's all you can say in step 4, reject the null or do not reject the null. And then the summary statement is always about the claim, and there are 4 possibilities for every summary statement. The 3 setups here in the middle refer to step number 1, stating the hypotheses and identifying the claim. You have a null hypothesis and an alternative hypothesis. The null hypothesis is H sub 0, and the alternative is H sub 1 or H sub A. I like H sub 1. When you have a two-tailed test for the mean, it would look like this. If you have a right-tailed test for the mean, it looks like this. And if you have a left-tailed test for the mean, it looks like this. This is with respect to the old edition of the textbook. They use phrases like at most and at least, so the inequalities less than or equal to, greater than or equal to are appropriate. The new edition of the textbook differs just a little bit with the 3 possible setups for these hypotheses. The null hypothesis with the two tail is equal to a number, the null hypothesis with the right tail is equal to a number, and the null hypothesis with the left tail is equal to a number. You always have strict equality in the null according to the new edition of the textbook, and you will see that in your Connect Math quizzes. I like the old edition because even though the new edition has made some changes, they are still using phrases like at most and at least. So I think it's important to have these inequalities at most and at least. There is a trick to the memorization of the 3 possibilities. Equality is always part of the null, but it's never part of the alternative. Not equal to, greater than, and less than. Also, greater than points to the right, so it's right-tailed. Less than points to the left, so it's left-tailed. The claim in one of these word problems could either be the null or the alternative. It cannot be both. And I wanted you to see that. The summary sentence is always about the claim, and there is a diagram that shows you the 4 possibilities of the summary sentence. Even though we go through the 5 steps of hypothesis testing correctly, and I like to tell the students that you receive a grade of 100 or A++++, there's always a possibility that you make a wrong decision in rejecting the null or not rejecting the null hypothesis. Here are those types of errors. Error number 1 is a type 1 error. it is called alpha, which is known as the level of significance. And you know you need alpha to determine critical values in step number 2 of the traditional method. But it's also the probability of rejecting the null, that's our decision, but it could be true. So rejecting the null when it could be true could be a mistake. Type 2 error is beta, and it's the probability of not rejecting the null when it's actually false. So not rejecting something that's false is a mistake. Will we ever know that it could be actually true or actually false? No, but these are the possibilities or probability of making a mistake in our decision. So alpha is the probability of rejecting the null when it's actually true. Beta is the probability of not rejecting the null when it's actually false. And alpha is also the level of significance, and it is used to determine critical values. And we need critical values to help us make our decision, and I'll show you that in these word problems. So you can actually refer to this sheet for the entire chapter. As we move to proportion testing, the parameter will change from mu to p, but the setups are still the same. As we change to chi-square testing, the parameter will change from mu to either sigma squared or sigma, depending upon if we're testing true variance or true standard deviation. The second sheet of your handout, and these sheets again will be attached to your test. The second sheet of your handout breaks down the traditional method and the p-value method with the 5 steps. Again, they always agree with decision, and they always agree with the summary statement. The main difference between the two methods is how you come to that decision, and I'll teach you both methods. The TI-84 calculator is most valuable when it comes to the p-value method. Next step. Page 3. Page 3 has a list of the phrases that you'll need. And these phrases come from the paragraph, and if you can pick out the phrase, you can pick out the symbol. Once you know the symbol, you can identify the symbol here, and that will tell you if it's a right-tailed, two-tailed, or left-tailed test. From the phrase to the symbol to this sheet allows you to set up your hypotheses and identify the claim. Remember, from the phrase to the symbol to this sheet allows you to set up the hypotheses and identify the claim. And then the last diagram is that about concerning the summary statement. You will put your left finger on, the claim is the null, or you'll put your left finger on the fact that the claim's the alternative. You have to decide that. And your right finger will go on what you decided to be your decision. And where your two fingers meet in the chart, you could either say there is enough evidence to reject the claim, there's not enough evidence to reject the claim, there is enough evidence to support the claim, there's not enough evidence to support the claim. And these are the only 4 possibilities for summary statements. Finally, attached to your test, I will be attaching the Z-table, the 2-page Z-table. And that's from Chapter 6. I will also be attaching the T-table, and that's from Chapter 7, the student T-distribution. And finally, I will attach the chi-square table, which is also from Chapter 7, those chi-square intervals, the chi-square distribution. That means that 6 pieces of paper will additionally be attached to your test number 4. The first lecture that I wanted to create with you, or for you, pertains to the overall outline of hypothesis testing. So I would like to go over those. Remember, this is the branch of statistics that deals with inferential statistics. We study samples to infer things about the entire population. Hypothesis testing is a decision-making process for evaluating claims about a population parameter like the mean, proportion, true variance, true standard deviation. There are 4 types of tests in this entire chapter. The Z-test for the mean, and you've got to meet these conditions. Only one condition has to be satisfied to make it a Z-test. You'll use the Z-table. The T-test for the mean, both conditions have to be satisfied to make it a T-test. You use the T-table. Z-test for proportion, no conditions. You do know that you need to use the Z-table. And the chi-square test for true variance and true standard deviation, you will use the chi-square table. When I say use the table, you would use those tables to find either the critical values in the traditional method or the p-value in the p-value method. And I will be showing you how to receive those values. No matter what kind of test we undergo, all problems can be solved by the two types of methods. Each method has 5 steps, and we will know both methods in the chapter. And I'm not going to read over the details now because I think that that will come into play once we actually start working the problems together. The first step of the traditional method is to state the hypotheses and identify the claim. And the claim is either going to be about the true mean, true proportion, true variance, or true standard deviation. Reading the word problem with its expressions and then the chart of expressions that I gave you will help you with the setup. Again, if you can pick out the claim and the phrase, you can go from the phrase to the symbol. And if you know the symbol, then you will have your setup: two-tailed, right-tailed, or left-tailed. H sub 0 is the null and H sub 1 or H sub A is the alternative. And the only thing that changes with the 3 setups will be the parameters, depending upon the type of test, from U to P to sigma squared to sigma. There is a new addition difference that I wanted to address once again. The Connect Math and new edition of the textbook, for the two-tailed, the null is equal to. For the right-tailed, the null is equal to. And for the left-tailed, the null is equal to. And that's really the only difference between the old edition and the new edition. The claim is always given in the word problem, and the claim can be the null or the alternative, but it cannot be both. Again, if you know these expressions, you can pick out the symbol. From the symbol, you can pick out the appropriate setup. Step number 2 would be critical values that you either find from the Z-table, the T-table, or the chi-square table. And I'll teach you how to find critical values for a two-tailed Z-test for the mean, a right-tailed Z-test for the mean, a left-tailed Z-test for the mean. And for every type of test here, how to find those critical values from the appropriate table. Basically, we need to know alpha to find critical values, which is called the level of significance. And it's also the probability of a type 1 error. Rejecting the null when it could be true would be a possible mistake. Rejecting something that could be true is a possible mistake. But it is used to find critical values. Here's an example of just steps 1 and 2, and this is just the Z-test. A psychologist feels that playing soft music during a test will change the results of the test. The psychologist is not sure if the grades will be higher or lower. In the past, the mean of the scores was 73. The word was means equal to. Now, you could go to your phrases that you have, and you could look that up, and you would see that that means equal to. But the claim is that the psychologist is not sure if the grades will be higher or lower. So the setup here is, since was means equal to, we have equal to in the null and not equal to in the alternative. The claim is that there will be a change. The psychologist doesn't know if the grades will be higher or lower, but the psychologist is claiming there will be a change in the test scores. And then the null says there is no change. There is no difference in the test scores. So this is a two-tailed Z-test. And if we say that it's a two-tailed Z-test and we know that alpha is 0.005, find the critical value or values. There will be 2 critical values, a positive and a negative, from the Z-table for this Z-test for true population mean. By the way, I actually did this one semester. I played Christmas music at the end of the semester to see if students would be able to maybe relax a little bit more. It was during final exam time. I did not perform this type of test, but I did have some people comment. Most people enjoyed the Christmas music. Some people did not, and it may have been my selection. I did play a little bit of Elvis and some other types of musicians during that period, so maybe they did not enjoy my music selection. But I had fun that day changing the Christmas songs and but I don't know if the students benefited or not because I really never tested this hypothesis. But this psychologist is testing it, but not sure if the grades will be higher or lower, but there's going to be a change. That's what the claim is all about. There will be a change in the grades. So if alpha is 0.005 and it's a two-tailed z-test, then we go and we draw our z-axis. We shade our left tail and our right tail, which are called rejection regions. Divide alpha by 2 only if it's a two-tailed z-test for the mean. And that's 0.0025. And that makes the unshaded areas 0.4975. Together, they have to add up to 50% on either side of the mean because the total area under the curve is 1. You could either do invert the norm, 0.0025, and get a negative 2.81, which is plus and minus, or you could look up this area in the two-page z-table. If you look up this area in the two-page z-table or the area closest to it and work your way to the outside of the z-table, you will get a negative 2.81. So the rejection regions are plus and minus 2.81 for this two-tailed z-test for the mean. And again, divide alpha by 2 if it's a two-tailed z-test. The test statistic formula or test value, sometimes I do say TS. The z-test has two possible formulas. It's either sigma over the square root of n or s over the square root of n. Remember, sigma is known or n is at least 30. So in the cases when sigma is not known, you're going to be using sample standard deviation. That means the sample size had to be large enough to make it a z-test. Sometimes both conditions can be satisfied, but you only have to satisfy one. The t-test formula test statistic is this, and we have worked with these formulas before. The mu that you see here is coming from the claim statement, so go to step number 1, your setup, for you to see what you would plug in for mu, and it's all about the claim. Proportion z-test test statistic is p hat minus p divided by p times q divided by n, and that's divided by the square root of p times q divided by n. P hat is sample proportion, and we learned that from Chapter 7. It's x over n. So in a class of 40 students, 30 go home over Thanksgiving. 30 out of 40 is 75%. P is coming from the claim statement in step 1. And this is very important. This is not p hat times q hat, but it's p times q. And P is the claim. P plus Q must equal 1. So you'll know the claim, but you will not know Q unless you use the relationship that P plus Q must equal 1. And then chi-square testing, n minus 1 times s squared over sigma squared. This sigma squared is coming from the claim, which is step 1. And the S, sample standard deviation, or the S squared sample variance will be given to you. Or perhaps you'll have to calculate from raw data. You will utilize these particular formulas when you go to calculate your test statistic, which is step number 3 of the traditional method. Make the decision. And this is my favorite part. Reject the null or do not reject the null. If the test statistic falls in the rejection regions, the shaded regions, and those are the regions determined by your critical values, then the statement says reject the null hypothesis. If the test statistic falls in the non-shaded, non-rejection, non-critical regions, then you do not reject the null hypothesis. And for a two-tailed z-test for the mean, or two-tailed t-test for the mean, or two-tailed proportion z-test for the mean, you'll have two critical values. One is negative, one's positive. For the right-tailed z-test or right-tailed t-test, you'll have one critical value. It's positive. And for the left-tailed z-test, left-tailed t-test, left-tailed proportion z-test, you have one critical value, and it's negative. Once again, there are important concepts. Even though you go through all 5 steps correctly, there's still the possibility that you make a mistake. And alpha is the probability of rejecting the null when it could be true, which is a type 1 error. And beta is the probability of not rejecting the null when it's actually false, and that's a type 2 error. The summary statement, again, only 4 possibilities. You put your left finger on the fact that the claim's either the null or the alternative, and your right finger on the decision that you just made in step 4. Where your two fingers meet, that will be your summary statement. And you're done with the problem after the summary statement. The 5 steps of the p-value method are very similar to the traditional method. For example, step number 1 is the same, the setup, state the hypotheses, identify the claim. But instead of finding critical values, we will jump to the step that says find test statistic from formula. And then we find the p-value from the test statistic and the tables. And I'll show you how to do that for every type of test. From the p-value, and the calculator TI-84 will give you the p-value as well. To make the decision, we take our given alpha level of significance and compare it to p-value. If alpha is greater than or equal to p-value, reject the null. If alpha is less than p-value, do not reject the null. And then, again, you go to the summary statements. I will tell you this, the p-value and what it actually represents is discussed in detail in the textbook. In the past, I would actually discuss what it actually represents and the definition of the p-value, but it seemed to confuse students. So if you would like to read about that, please do. What I'm just going to do in this particular chapter is tell you how to find the p-value from the tables and the test statistic. And then the last page of the overview, and that will conclude lecture number 1, is just to remind you that we'll go over traditional method first and then p-value. Regardless of method, the hypotheses, the test statistic, the decision, and the summary are the same. Finally, the calculator. I will show you where to go here. It will be stat, arrow over to test, and z-test is number 1, that's the z-test for the mean. T-test is number 2, that's the t-test for the mean. 1 prop z-test is number 5, that's the 1 proportion z-test for the mean. And it does not have chi-square testing. If you scroll all the way down, I know it says chi-square test, but believe me, that's not the chi-square test that they're asking for. So I'm going to opt out of that. Stat, test. So for this test, number 4, chapter 8, you'll use number 1 and 2, and then number 5. 1, 2, 5. Z-test, T-test, 1 proportion Z-test, the chi-square testing, you're on your own. Unless you download the program from the CD that came with your textbook to your calculator, and you're more than welcome to do so if you would like to do that. That concludes the overview. The next lecture will pertain to the Z-test problems, and we will cover the traditional method and then the p-value method. Thank you. God bless you.